Question number 4. So in this question, we need to convert a number from decimal to binary using recursion. So as always, we need to think about our first step. So our first step is to find a recursive case. So we know that to find the recursive case, we need to understand our problem. So first of all, let's see how can we convert a decimal number to a binary mathematically. So to do so, we have a standard conversion steps like this. So the first step is we are dividing the number by 2. Then we get the integer quotient for the next iteration. Then we are getting the remainder for the binary digit. And then we repeat these steps until quotient is equal to 0. Now initially you might not understand these steps over here. Now let's look at an example to understand this very clearly. So for example, if we want to convert 13 to binary number, the first step says that we need to divide it by 2. So we are dividing by 2 and we are getting quotient and we are getting the remainder. So we are getting the quotient for the next iteration and we are getting the remainder for binary digits. So this is for binary digit and this is for next iteration. So this means that in the next iteration we are going to divide this quotient by 2 one more time. So if we divide it by 2, you see that 6 divided by 2 is 3. So the new quotient is 3 and the remainder is 0. So we are keeping this number for binary digit, then we are continuing to the next step. So in the next step we are dividing 3 by 2, so the quotient is 1 and the remainder is 1. So one more time we need to continue to the next step until we reach that quotient is equal to 0. So in the next step we are going to divide 1 by 2, so the quotient is 0 and the remainder is 1. So this is how we are converting a decimal number to the binary. Then at the end we need to join these numbers from down to top. So equivalent number of the binary for 13 is going to be 1101. So we are starting from here 1101. Now let's look at one more example. So for example, if you want to convert 10 to binary, then in this case one more time we are going to divide 10 by 2. So the quotient is 5 and the remainder is 0. Then in the next step we are dividing 5 by 2, so the quotient is 2 and the remainder is 1. And then in the next step we are dividing 2 by 2, the quotient is 1 and the remainder is 0. And at the end we are dividing 1 by 2, the quotient is 0 and the remainder is 1. So if we join these numbers from down to top, the binary digits will be like this, 1010. Now that's how we convert a decimal to binary. So the point is we need to define the recursive case for this method. So without recursive case, it's not possible to develop a recursion function for a given problem. So here, this is just a little bit tricky, but if you do more practice, the things become more clear. So if you look at this, our second example over here, in which we convert 10 to binary, here we combine, so here we are combining the remainders and getting the binary over here. But you might be thinking that where is the recursive case over here? So how can we identify the recursive case? But here, if you look at these numbers carefully, for example, so if I take the last remainder over here and multiply it with 10 and plus 0, I will get 10. So which is the first 2 digits of the binary number. Then I'm going to repeat this step for the next iteration. So in the next iteration, I'm going to multiply 10 with one more time to 10 and plus this remainder over here. So if I multiply 10 with 10, I'm going to get 100 and plus 1 is going to be 101. So this means that we have found first 3 digits of this binary over here. So which is 101 and here also we have 101. Now if I continue to do the same operation, for example, 101 multiplied with 10 plus 0 is going to be 1010. So this is the number that we have when we convert 10 to binary. So we are doing these steps over here to find the recursive case. So if you look at these operations from top down, you can see that we can write our recursive method like this. So here fn, n is 10, is equal to 10 is divided by 2 and the remainder from here. So in this case it's 0 plus 10 multiply with the answer that comes from the next iteration. So we know that from the next iteration we have 101. So we are multiplying with 101 plus 10. So this continues until we reach the quotient is equal to 0. Now let's implement this equation as our recursive case in Java. So I'm going to declare our method over here. So it's going to be public int, is going to return int, and the name of method will be decimal to binary. So as a parameter, it's going to take integer n, Then here I'm going to return n mod 2, so which is the remainder from dividing by 2, plus, and we are calling this method recursively for n divided by 2. So this is it. Now let's run this method to see what's happening. So now here I'm going to create variable result. So it will be result from this method. So here is going to be main dot, and for example let's find it for 13. So I'm going to print out result to the console. So if we now run our code, you see that our code runs infinitely. So the thing over here is that we need to find a recursive case to prevent this infinite loop over here. So as always, as I said, when you are thinking about base condition, you need to look at the definition of the problem. So now here I want you to pause the video and try to find out base condition by yourself. Now hopefully you have found it. So if you haven't found it, let's find it together. So when we look at the definition of the problem, it says that we have steps over here to find the binary tip. Now at the last step it says that repeat these steps until quotient is equal to 0. So this means that when quotient is equal to 0, then in this case we need to stop. So we can write our base condition based on these steps over here. So here when n reaches to 0, we need to return 0. If n, and in this case I'm going to return 0. Now if we run our method for 13 one more time that we calculated before, now you see that it's returning 3, so this means that we did something wrong. Now if we go to our definition one more time, you will see that we are missing 10 from our equation. So when we are writing the recursive case, we miss 10 from here. So I'm just going to put 10 over here and run our code. Now in this case you will see that it returns 1101. So this is the number that we have calculated in our previous slide. So if I put for example 10 over here, so it should return 1010 1010. Now you see that the answer that we get is 1010. So this is the number that we have calculated before. Now with this we have finished our method. So our method works the way that we want. Now we need to check our last step, in which we need to check unconditional cases. Now here unconditional case might be if you are not putting an integer number over here, but in this case Java prevents this case, so we don't need to put an extra condition over here, because when you put any float number over here, for example if I put 1.5, you'll see that Java raise error, but in some programming language you need to put another base condition over here to get rid of this error. But in this case Java itself prevents it, so I'm not going to put any condition over here. Now with this we have completed our function, so hopefully everything is clear about this function. So in this lecture we have created a function which converts decimal numbers to binary numbers. So hopefully everything is clear about this. So see you in the next lecture.